Here are the video solutions for NCFE Functional Skills Maths Level 2. This is Section A, which is the non-calculated section from 2023. Okay, so let's take a look at question number 1. So all we need to do, we don't really need to read the waffle, we just need to increase 4,650 by 2%. Okay, so first of all I'm going to work out, well, what is 2% of 4,650? So 1% is going to be this figure here divided by 100, so 46.5. So therefore 2% is going to be 46.5 plus another 46.5. Put a decimal point in line in the answer box. 5 plus 5 is 10, 0, carry 1. 6 plus 6 is 12, plus 1 is 13, carry 1. 4 plus 4 is 8, plus 1 is 9. So 2% is 93. So all I need to do is add 93 to 4,650. Or you could add 100, take away 7, but let's just do it as a column. 0 plus 3 is 3, 5 plus 9 is 14, carry the 1. 6 plus 1 is 7, 4 plus nothing is 4. So the answer is 4,743. Okay, part B. So first of all, we're going to round these to 2 decimal places. So 2.678. Well, if we're rounding that to 2 decimal places, that is approximately, we're just looking at the second decimal place, so this 8 we can completely ignore. 7 is greater than 5, so the 6 will move up 1 to a 7. And let's have a look at 0.6214. That is the approximately, again, 1 decimal place. We're interested in this figure here. It's less than 5, so that will round down to 0.6. Okay, so we know that, so we're saying that in the race on Saturday, each lap was 2.7 miles long, and we're saying that 1 kilometre is 0.6 miles. We use these values to estimate the length of the lap. So we know that 1 kilometre is approximately 0.6 miles, and we're trying to convert 2.7 miles. Okay, so how many times greater than 0.6 is 2.7? Well, the answer to that is, what is 2.7 divided by 0.6? Now 2.7 divided by 0.6 is the same as 27 divided by 6. When you're dividing by a decimal, well, you want to try and avoid dividing by a decimal, and to avoid doing that, multiply both numbers by 10, and that gets rid of the decimal. And a lot of people seem to be confused as to why that works, but I always say to people, well, what is 8 divided by 4? The answer is 2. If you multiply both these numbers by 10, you get 80 and 40. What's 80 divided by 40? A lot of people seem to think the answer is 20, but no. How many 40s go into 80? Well, it's still 2. So by multiplying both numbers by 10, you still get the same answer. So that is why 2.7 divided by 0.6 is the same as 27 divided by 6. So we might need a bus stop here. How many 6's go into 2? 0, move the 2 across. 6's into 27, go 4 times with the remainder of 3. Now I need to put in a decimal point and a 0 now, so I can park the 3 onto that 0. 6's into 30 is 5. So the answer is, well, since to go from 0.6 to 2.7 we are multiplying by 4.5, we need to multiply the 1 kilometre by 4.5, but of course 1 times 4.5 is 4.5, so the answer is simply 4.5 kilometres. Okay, so here we are comparing the median and the range for Ralphie. So let's first of all work out the median. So the median is the middle, but we need to put them in order. Now, just for the sake of ease, I'm going to ignore, they all begin with is 1 minute. So I'm just going to ignore the 1 minute for now when I put them in order. So I'm just looking at the rest. So I've got 16.008. So I'm putting them in order from smallest to largest. 16.810, 17.841, 17.986, then it's 18.462, 19.148, and then 21.467. Okay, so to find the one in the middle, I'm going to cross off the one on the left and the one on the right, and I'm going to do that again and again until I've got the median. So the median, actually let me just write a little table here. So we've got Damon and we have Ralphie. And okay, so the median for, okay, this is Ralphie, is, remember, it's 1 minute 17.986 seconds, and for Damon it was 1 minute 17.924. Now for the, we also want to work out the range, since we've worked, well, we want two comparisons, so we're going to make one comparison based on the median and what second comparison based on the range. So Damon was 4.812. So the range is the highest minus the lowest. So I'm just going to scribble this over here. So remembering that it's 121.467 and 116.008. So we want to do a subtraction here to work out the range. Biggest, take away the smallest. 6 becomes 5, so that can become a 17. 17 take 8 is 9. 5 minus 0 is 5. 4 minus 0 is 4. Okay, 2 becomes 1. 11. That 1 becomes an 11. 11 take away 6 becomes what's 11 take away 6? Struggling with that, is 5. Okay, so the range is 5.459 seconds. Okay, so comparing the medians. So here, this is a comparison of average. So we can say that on average, so who's faster? Well, the fastest person would have the lowest time. So Damon is faster. And the other comparison is due to consistency. Okay, so range is all about consistency. Now, the lower the range, the more consistent. So we can say here that Damon is more consistent. As the range is lower. Okay, so median, we're making a comparison about average, and range, we're making a comparison about consistency. And we are done. Okay, moving on to 1D. Damon drives along a straight part of the track at an average speed of 126 miles per hour, completing this in 47.5 seconds, and we want the length. So the length, this is in the distance. So we need to recall the basic formula, which is speed is the distance divided by time, but we want the distance, so speed multiplied by time gives us the distance. So we've got a speed which is in miles per hour, and we've got a time which is in seconds. Now that's going to cause a bit of a problem because we've got here hour and seconds. So either we convert the seconds into hours, and I would not recommend doing that because 47.5 seconds is such a short amount of time that turning that into hours will result in a very weird, a tiny decimal. So I would convert 126 miles per hour into miles per second. So first of all, 126 miles per hour, I'm going to turn that into miles per minute. Now, we know, of course, that there are 60 minutes in an hour, so if it's this number of miles in an hour, it's going to be 60 times less in a minute. So I need to divide 126 by 60. Now 126 divided by 60, that is the same as 12.6 divided by 6. And we saw a few questions ago how when you're dividing you can multiply both numbers by 10, that helped get rid of a decimal, I seem to remember. But we can do the same here, which is divide both numbers by 10, it's still the same answer. Now 6 is into 1, don't go, move the 1 along. 6 is into 12, goes twice, point, should have put that in at the start, and 6 divided by 6 is 1. Okay, so 126 miles per hour, that is 2.1 miles per minute. Now I want this in miles per second, so I need to divide it by 60 again. Now 2.1 divided by 60, that is the same as 0.21 divided by 6. just don't really want to divide by anything other than a single digit number. So 6 into 0.21, let's put the decimal point above. 6 is into 0 is 0. 6 is into 2, don't go, move the 2 across. 6 is into 21, goes 3 times with the remainder of 3. Run out of digits, so I'll stick in a 0, so I can put the 3 on there, and I get 0.035. So that is the... so we've done quite a few calculations, and we might be forgetting what we've actually done here. So what we have done here is turned 126 miles per hour into 0.035 miles per second. Now, the distance is the speed times the time. This is the speed, this is the time, this is miles per second, this is in seconds. So what we need to do now is simply 47.5 multiplied by 0.035. I say simply, it's not that simple. So I'm going to multiply 475 by 35, pretending that they are not decimals. 5 5s are 25, carry 2. 5 7s are 35, 36, 37, carry 3. 4 5s are 20, plus the, I forgot, was that a 7 I carried over there? 5 carry the 2. No, it was a 3. So 4 5s are 20, plus the 3 is 23. Okay, putting in a 0 because this is the 3 of 30. 3 5s are 15, carry 1. 21 plus the 1 is 22, carry 2. 3 4s are 12, 13, 14. Okay, so let me just scroll down a little bit so that I can add these two together. 5 plus 0 is 5. 7 plus 5 is 12, 2 carry 1. 3 plus 2 plus 1 is 6. 2 plus 4 is 6, and 1 plus nothing is 1. So we know that 475 multiplied by 35 is 16625. So 47.5 multiplied by 0.035 is going to be, well, these same digits, but we need a decimal point somewhere. So what we need to do is count up the number of decimal places in the question. Well, there's 1, 2, 3, 4. So therefore 1, 2, 3, 4. So there is our answer, 1.6625 miles. Quite a challenging question, that one. Okay, moving on to 1E. So this question is not too bad. So all we need to do is add together the fractions to work out the fraction that accompany A or B. So 2/3 plus 1/7. I'm going to do crisscross smiley face. So 2 times by 7 is 14, plus 1 times by 3 is 3, all over 3 times 7 is 21. So that comes to 17 over 21. So the rest are company C. So if 17 out of 21 are A and B, then the remainder, which is going to be is company C, which is going to be 4 over 21. Okay, right, and let's take a look at question 1F. Probably the easiest question of all so far. I just need to add these two numbers together. We just need to make sure that we line them up correctly. So in other words, the 674 needs to go under the 540 because we always line them up from the right hand side. So it should be a relatively easy bit of addition. 6 plus 7 is 13, carry the 1. 5 plus 0 plus 1 is 6. 8 plus 9 is 17, carry 1. 4 plus 1 is 5. 4 plus 7 is 11, carry 1. 5 plus 1 is 6, plus the other 6 is 12. 2 carry 1. 1 plus 1 is 2. So the answer is 2, 2, 1, 5, 7, 6, 3. Of course, you don't have to put the commas in. I prefer to do that, but yeah, you don't need to have them, as I said. So there we go. That is the end of this test. This is section B, which is the calculator section. So question 2A. So all we have to do here having a calculator is not in the slightest bit useful, is write this number, or write the number that's been described in words in figures. So what you need to do is just remember that, let me just write a number randomly. As we count from the right, after every 3 we put a comma, after every 3 we put a comma, and we need to remember that this first comma here represents the word 1,000 and the next comma represents the word million. So if we're writing 3 million and some stuff, then we need 3 followed by a comma. Now before the next comma we just need to write 400 because the word 1,000 is the next comma. So there's 400, comma, and afterwards we need to write 19, but it's always in groups of 3, so we can't just write 1, 9, it's going to be 0, 1, 9. So there we have it, 3, comma, 4, 0, 0, comma, 0, 1, 9. Of course you can take the commas out at this stage, but putting the commas in definitely helps when you're writing it, remembering that you use a comma for the word million and a comma for the word 1,000. Okay, so there are 216 guests, 81 of which are signed up to the loyalty program. Fiona thinks that more than 4/10 are signed up to the loyalty program. So what we need to do is work out, well, what is 4/10 of 216? So when you're working out a fraction of a total, you take your total, you divide it by the number on the bottom, and then you multiply it by the number on the top. So grabbing your calculator, 216 divided by 10 is 21.6. Multiply that by 4, we get 86.4. Okay, so 4/10 is 86.4. 81 are signed up to the loyalty program. Fiona thinks that more than 4/10 are signed up. Well, that's incorrect. So we can say Fiona is wrong, as 86.4 is greater than 81. Okay, part C, we need to be really careful here because it does say here more than the mode. Okay, so the mode is the most common. So according to this, more people stay for 3 nights than any other night. So 3 nights is the mode. So if you stay longer than a mode, you get £10 off. So these people here would have got the £10 off voucher. So we just need to add 25 plus 16 plus 5 plus 4. And if we add all that together, let's just grab a calculator. 25 plus 16 plus 5 plus 4 is 50. So 50 people get the £10 off. So that's 15 times by £10, which is £500 in total. And we've not actually looked at what the actual question says. I've sort of gone ahead. We know that so £500 worth of vouchers was given out on the Sunday because this refers to Sunday, and on the Monday it's 4% more than this. So we need to increase 500 by 4%. So when we're increasing by 4%, we need to multiply by 1.04. Now, if you don't really understand your percentage multipliers, remember that if you're calculating 4% of an amount, the multiplier would be 0.04. And the 0.04, this is the decimal equivalent of the percentage amount. In other words, it's this number here divided by 100. Now, this is the multiplier you would use to calculate 4%. And if you want to increase by 4%, then you just add 1 to 0.04. So 0.04 plus the 1, that gives you the 1.04. That just means we can do this calculation in one hit. Otherwise, we could have multiplied 500 by 0.04 and then just added it to the 500. That would have been perfectly acceptable as well. And 500 multiplied by 1.04, that comes to a total of £520, which is our answer. Okay, so 2D, a lot of reading to do, but it's relatively straightforward, this question. Here is your formula. We know what L, S and R stand for. So Mrs. Jones stayed for 3 nights in a suite, so S is 3, and a regular room 7, so R is 7. Let me make that look a little bit more like a 7. So our calculation is, so L is the loyalty number of loyalty points. So that's going to be 300 multiplied by S, which is 3, plus R, which is 7 over 2. Now 7 over 2 is 3.5. 3.5 plus 3 is 6.5. So L is going to be 300 multiplied by 6.5. So L comes to 1,950 points. And 1,950 points puts us in tier 3. So lots of words, but not really that challenging in the end. Okay, so here we know that 1 inch is 2.54 centimetres. Sorry, this is the symbol for inches, and we want 60.3 inches. So that is just going to be 60.3 lots of 2.54, and 60.3 times by 2.54 is 153.162, but we want the answer to 1 decimal place, so that means we are interested in the value of the 2nd decimal place, the 3rd decimal place, and well, anything after that just ignore. If this is 5 or more, then the column to the left moves up by 1. Well, 6 is greater than 5, so the 1 will become a 2. So this is 153.2. Okay, on to 2F. So we've got, well, we know this is a line of symmetry. Well, this is the only place where the line of symmetry could be. So what we have here is we have a trapezium. Now, what is the formula for the area of a trapezium? It's 1/2 of A plus BH, where A and B are the parallel sides, so these sides here are parallel, and H is the height of the trapezium. Okay, so let's just work out one trapezium to begin with. So that is going to be 17 plus 20.5, whatever that is, multiplied by the height, which is half of 23. Half of 23 is 11.5, and then that is going to be divided by 2. So this is for one trapezium, but we've got 2 of these trapeziums. So instead of, well, we can just say it's 2 lots of this, but if it's 2 lots of all this stuff divided by 2, then these 2 2's can cancel each other out. Hopefully that makes sense. If it doesn't, work out the area of one trapezium using this formula, and then just double it and you've got the area of the whole thing. So 17 plus 20.5 comes to 37.5 multiplied by 11.5. So the area of the whole thing is 431.25 square meters. Okay, now on the dance floor, each person needs 0.9 square meters. Not a lot of space, but anyway. So how many 0.9s go into this? So the calculation is 431.25 divided by 0.9, and if I divide that by 0.9, I get 479.16 recurring. So we'll just round that down, not because it's closer to 479 than 480, but just because, well, 480 would mean each person would not have 0.9 square meters of floor space, be a bit restrictive, so we'll just round that down, so that is 479 people. Okay, on to question 3. It's simply asking us what is the name of this shape. Well, what we've got here is we have a triangular face at the front and the same size triangular face at the back. Now, if I were to get a saw and cut anywhere down the middle, I would still have this the same triangle. Basically, it's a triangle all the way through. Now, so the cross section is triangular. Now, because the cross section is consistent from this face here all the way through to this face here, then this is the definition of a prism. So the answer is C. It's not a cylinder, because a cylinder you would be expecting a circular face, top and bottom. A pyramid, I suppose you could be tempted into thinking it's a pyramid, but with a pyramid, all the triangular faces converge together at one single point here. So it's not a pyramid, and a cuboid is just well, just a box really. So this is what a cuboid would look like. So it would have a square or rectangular face as its cross section, not a triangle. Okay, question for 3B. So all we need to do is, we've been told, well, we just need to use this formula here. So this is the formula for the surface area of a cone. So it's pi r squared. So we've been told that pi is 3.14. So that's 3.14 multiplied by the radius squared. So times 7 times by 7 plus pi rs. So that's pi times by r, which is 7, multiplied by the slant height, which is 24. Okay, so 3.14 times by 7 is 153.86, and 3.14 times 7 times 24 is 527.52. And now all we need to do is add these two values together, and we get a total of 681.38 millimeters squared. Okay, question 3C. So we've been told that the paint is being mixed in a ratio of 4 to 2 to 1, and that is blue to green to yellow. Okay, so what I'm going to do is work out what fraction is blue, what fraction is green, and what fraction is yellow. Well, 4 plus 2 plus 1 is 4, 5, 6, 7. So that is 4/7 blue, 2/7 green, and 1/7 yellow. Okay, so turning ratios into fractions is often a very useful first step, and the denominator or the bottom number of the fraction is simply the ratio numbers added together. So if Callista is making 14 litres of teal coloured paint, now 1/7 of that needs to be yellow. So what is 1/7 of 14? Well, the answer to that question is, what is 14 divided by 7? 14 divided by 7 is 2. So she needs 2 litres of yellow. She thinks she needs 1.6 litres of yellow, so she's not correct. And so the answer is no, she needs 2 litres. Okay, right, moving on to 3D. So here we've got a little intro here. The graph below shows the information about the settings and fault rate of a machine in the toy factory. Okay, so what was the highest fault rate when the machine was set to make 1600 toys per hour? Okay, so number of toys made per hour goes across the bottom, so 500, 1000, 1500, we want 1600, so it's between 1500 and 2000, and we're simply going up in 100s, 1500, 1600, 17, 18, 19, 20. Okay, so we've got 3 values on 1500, we've got 1, 2, 3, and we want the highest fault rate. Well, the highest fault rate, so the fault rate is over here on the y-axis, so just take this value over here and we can see that the answer there is 20 faulty toys per 1000. Okay, on to question 3E. Okay, so Callista's writing a report. She uses a line of best fit to find the fault rate when the machine setting is 2500. Okay, right, so what we need to do first of all is draw in a line of best fit. Now this is going to be quite tricky for me because I'm just going to be freestyling this, but you should be definitely using a ruler and a pencil. So what I need to do is draw a line that cuts through the middle of the data, trying to keep more or less the same number of dots above and below the line. Now of course my line is freestyle, so it won't even be straight, but let's see what happens. So it's going to be something, actually that's not too bad. Okay, so it's not perfectly straight, but that will do. Well, it's the best I can do. I'm not going to redo it. Okay, so the fault rate when the machine setting is 2500 as a percentage of the median fault rate when the machine setting is 2600 is more than 90%. Okay, so this needs to be read several times. So first of all, I'm going to work out, well, what is the median fault rate when the machine setting is 2600? Okay, so 2600 is here. So we can see there are actually 3 values for 2600. Now the median is the one in the middle. So the median is of the 2600 machine setting is this one here, which corresponds to 40, 42, 46, 40, 42, 44, 40, 48. Okay, so this question already will be a lot easier if you just turn all of this stuff here into 48. The fault rate when the machine setting is 2500 as a percentage of 48 is more than 90%. Okay, so what is the fault rate when the machine setting is 2500? And we've been told here she uses a line of best fit to find the fault rate when the machine setting is 2500. So this is where we might not 100% agree because it's unlikely that everyone's drawn an identical line of best fit. So 2,500, if I take it up to the line, it hits it just just here. In fact, it looks like it's between 40 and 42. Now yours may well go through 40, it may well go through 42, which is probably perfectly acceptable. So I'm just going to say that this is a 41. Okay, as I say, you may disagree with that, and that's totally fine. So basically the question is now, 41 as a percentage of 48 is more than 90%. Well, what is 41 out of 48 as a percentage? So if we're turning this from a fraction into a percentage, it's top divided by bottom multiplied by 100. So, oops, I've written times there, it should be divided. 41 divided by 48 times by 100, and 41 divided by 48 multiplied by 100, that comes to 85.416%. So is she correct? No, she's not correct. The percentage is let's call it 85.4%, and that of course is less than 90%. You may not have exactly the same percentage as me, and the reason for that is because well, you should hopefully be agreeing with me with the 48, but you may not have got 41 with your line of best fit, because your line of best fit may look slightly different, and that's totally fine as long as it's not miles away from, if you've got if your line of best fit for 2,500 is going through at 30, then yeah, that is definitely incorrect, but it should be somewhere around 40, 42-ish in my opinion. Okay, so for 3F, what we need to do is, well, we know that there are 26,000 toys made, and they've used between 0 to 30 cubic centimetres of plastic. Now, these 26,000 toys may have used exactly 30, or maybe 0.001. We don't know. So what we're going to do is assume that every single one of them was exactly halfway between 0 and 30, so 15. So I'm creating a column here, which is the midpoint of these ranges. So 15, 45, 75, 105, and 135. So if 26,000 toys were made with, we're assuming that our best guess is 15 cubic centimetres, then the total is going to be 26,000 times by 15. So I'm going to do another column here for our subtotals. So 15 lots of 26,000 comes to 390,000. 45 multiplied by 42,000 is 1,890,000. 17,000 multiplied by 75 is 1,275,000. 9,000 multiplied by 105 comes to 945,000, and 6,000 times by 135 comes to 810,000. So what I'm going to do is work out the total, the estimated total of all of the toys combined. So it's these figures all added together, and that comes to 5,310,000. So this is the estimated total volume of plastic, and we know that there is 100,000 toys made. So therefore, the estimated mean would be 5,310,000 divided by 100,000, and that comes to 53.1 cubic centimetres, and that is a value between 0 and 150, sort of kind of halfway through. Well, it's kind of in this category here. It seems believable anyway. Okay, so this is going to be reduced by 8%. Now, if you go to the shop and you're buying a pair of trainers that are 8% off, that means you pay 92%. So all I need to do is work out 92% of 53.1. You could work out 8% of this and then subtract it, but working out 92% is a lot quicker. Now the multiplier for 92% is 0.92. This is the decimal equivalent of this percentage figure. It's this percentage figure divided by 100. So it's 0.92 multiplied by 53.1, and that comes to 48.852, but we want one decimal place. So we're interested in the value of the second decimal place. It's a 5, so the column to the left will move up one, so that will become 48.9. Okay, so for this question we know that we're doing a square extension, and A and B represents one line of this extension, and this line is 1, 2, 3, 4, 5 along, so if it's a square it's got to be 5 up or also 5 down. Let's go down. 1, 2, 3, 4, 5. So another corner will be here and another corner will be here. So these are two coordinates. So we always do the horizontal first, so that is 4, 0 and 9, 0. Alternatively, if you go up, then 1, 2, 3, 4, 5, the corners will be here and here, in which case, let me just scroll down a little bit, the coordinates will be 4, 10 and 9, 10. So there's two choices here, 4, 10 with 9, 10, or 4, 0 and 9, 0. Okay, so here we want to draw first of all the side view. Well, if this is the front, then this here is the side and it is a trapezium. So just draw a trapezium. Obviously a pencil and ruler would be better than me just freestyling it. Again, I'll show that right angle is that part there, although it's fairly obvious because the higher point is here and the lower point is there, corresponding with these points here. And the front view, well, that is simply this part here, which as you can see is a rectangle. So the front view, all you need to do is draw a rectangle. Again, pencil and ruler would be best. Okay, for this question here we are simply using this formula here, using A, B, W and L. A and B are the greatest heights and the smallest heights. So here A is 3 and B is 2.5. They've put sort of hidden the 2.5 here, but this bit here is also 2.5. So that's A, that's B. The width and the length, well, it doesn't matter which is which, so because they're both 6. So there we go. So V is going to be 0.5 multiplied by 6 times by 6 times by A plus B, so 3 plus 2.5. So the volume is 0.5 times 6 sixes are 36, multiplied by 3 plus 2.5 is 5.5. So therefore V comes to 99. Now I'm not actually sure what the questions asked us to do really. We should have probably read ahead, but I'm sure working out what V is very important. Okay, so we're using this formula to work out the power of the heater needed, and we already know that V is 99. So the calculation is 40 V, so 40 times by 99 plus 100N, where N is the number of windows, and that's 2 windows. So 100 times by 2. 40 times by 99 is 3,960 plus 100 times by 2, which is of course 200. So that comes to 4,160. So that is our answer, 4,160. Okay, so let's take a look at this one. So the width of the garden is 11.8, and the drawing will use a scale of 1 to 200. So basically the scale drawing is 200 times smaller, or the garden is 200 times bigger than the drawing. So first of all, let's turn the 11.8 meters into centimeters. So that's 11.8 multiplied by 100. So that's 1,180 centimeters in real life. So the drawing is 200 times smaller. So all I need to do is divide this by 200. And 1180 divided by 200 is 5.9 centimeters. Okay, so is Abdul correct? No. The width should be 5.9 centimeters. Okay, moving on to 4E. Okay, so Abdul thinks that overall residential applications are more likely to be granted. So what I would do is work out, well, what percentage of major, residential and commercial are granted. So for major, it's 195 out of 270. For residential, that's 267 out of 306. And for commercial, that's 94 out of 124. So what I would do now is turn all of these into percentages. Now to convert a fraction into a percentage, it's top divided by bottom times 100. So 195 divided by 270 times by 100. That comes to approximately 72.2%. For residential, 267 divided by 306 times by 100 comes to 87.2%. And commercial is 94 divided by 124 times by 100, and that comes to just over 75%. So what did Abdul think? Residential applications are more likely to be granted than commercial. Is he correct? Yes, because 87.2% are approved, which is greater than 72.2% and 75%. Okay, so what is the probability that one of the applications chosen at random is a declined commercial application? Well, how many applications are there in total? Well, 270 plus 306 plus 124, it comes to 700. And of the 700, how many are declined commercial? Well, here's commercial, here is declined, and that is 30. So as a fraction, that is 30 out of 700, and that can be simplified to 3 over 70, and that fraction can't be simplified anymore. So there we go, that is the probability that any application chosen at random is a declined commercial, 3/70. Okay, so for this question, I would just tidy it up a little bit. 0.2, well, we're going to do the bracket, we need to do brackets first, so this is a question just checking our understanding of Bidmas. Let's do the bracket. 0.2 plus 0.05 is 0.25 times 6 squared over 0.9. We'll do the indices next. So 6 squared, that's 36. So 0.25 times by 36, and it's all of that is over 0.9. So let's sort out the top. 0.25 multiplied by 36 is 9, and 9 divided by 0.9 is 10. And that takes us to the end of the assessment.